In Chapter 6:13, a professional soccer player succeeds in scoring a goal on only 84% of his penalty kicks. Assume that the success of each kick is completely independent of the other kicks. So let's say he plays a series of games. What's the probability that the first time he fails to score a goal is on his 5th penalty kick? So if he's going to fail on the 5th kick, that means he's going to succeed on the first 4 kicks. Well, if he's going to succeed on the first 4 kicks, there's an 84% chance that he succeeds on the first, and an 84% chance that he succeeds on the second, times an 84% chance that he succeeds on the third, times an 84% chance that he succeeds on the fourth, and then he has to fail on the 5th. So on the 5th kick, there is a 16% chance that he will fail. So another way to write this is that he has to succeed 4 times, and then he has to fail 1 time. So it's the probability of succeeding raised to the 4th power times the probability of failing raised to the 1st power. And so if we multiply this out, we get about 0.0797. So there's about an 8% chance that he would fail on the 5th kick. Since we're looking for the first success or the first failure, this is a geometric probability question instead of a binomial question. So then if we ask, what's the probability that he scores on 5 or fewer of his next 10 penalty kicks? Now this is a binomial problem because the number of successes has been fixed. We're looking at 10 trials, and we're looking at 5 or fewer successes. So in this case, we're looking for the probability that x is less than or equal to 5, and we're looking at 10 trials, and the probability of success is equal to 0.84. Using my binomial formula, the probability of exactly 5 successes would be 10 choose 5 times 0.85 to the 5th power times 0.16 to the 5th power, because if we had 10 trials, 5 successes and 5 failures would add up to my 10 trials. But that's only for exactly 5 successes. So it's a little bit easier to do the calculation using your calculator, because we do not want the probability of exactly 5 successes. We want the probability that x is less than or equal to 5. And our calculator will do this for us when we do the binomial CDF calculation as opposed to the PDF. And so we would have 10 trials. The probability of success would be 0.84, and we're looking for 5 or fewer successes. So N, P, K. And make sure you mark the probability of each of these pieces if you're going to use this calculator notation here. And it turns out that probability is 0.013. That's about a 1.3% chance that if a soccer player could actually score about 84% of his penalty kicks, that out of 10, he only scored 5.5, or only scored 5 or fewer, So that comes into play in the next part of the question, which asks, suppose our soccer player is out of action because of an injury. When he comes back, he only scores 5 out of his next 10 penalty kicks. Do you think that that's enough evidence to show that his success rate is now less than 84%? And I would suggest that the answer is yes, because it is very unlikely that he will score only 5 out of 10. Or she. If his actual score rate was 84%. So if he did score 5 or fewer, it seems pretty reasonable that his rate had actually changed. So there were a couple of things I was looking for in the conclusion. The first thing was a yes vote. If you didn't have a yes vote, that was okay. You just had to really justify your no vote. So the yes vote was justified by saying it was very unlikely that he'd get the score of 5 out of 10 if his actual rate of scoring was 84%. So you kind of had to link those three things together. It's unlikely for him to get the score that he got if his percentage was what was actually claimed. All right, and that's it for number 13 and for chapter 6.